follow along with this, of course. Now, I'll get it. Go for Myers. Where did you put the paper? You brought it to this staff room? Upstairs?
I was listening.
Well, there are 3 floors, Mr. Abraham. And knowing that the second floor is the one with the 2 in front of it, it's probably in the middle of the first and the third. And they're only in pre-calc 11. Right? You're counting to 3, really. I'll sort it out.
That's on YouTube.
I was listening.
I said second floor.
1, 2, 3. 2 is in the middle of 1 and 3. Go get the boxes. Take them where they're supposed to go. Bert, are you really blaming somebody else for not being able to count to 3?
I said second floor. I messed up the whole thing.
All right. Every question on here is going to be worth 2. You're going to get 1 for the work. You're going to get 1 for the answer. Because you have to know when to stop. This is the work. This is the answer. If you did not complete the square, you do not get the 1 mark for the work, because I wanted you to use completing the square. Okay? Give yourself a mark out of 2. Ask questions now if you need to.
Can I simplify the root 18? Is it okay, right?
I'm going to answer Taylon's question because she was going to ask it and put her hand up and everything. But Ayaka sits at the front, so...
I couldn't see.
I know. Same question. What are you going to do? You want to simplify this? Yeah. That was what I was going to say next. 3 root 2. Will I accept that? Yes. Is that better? Obviously. Everybody good? Of course, if you didn't do it, what should you be doing right now? Writing it down as notes. Solve by the quadratic formula with exact and approximate answers. 2x squared plus 5x minus 8 equals 0. Minus 5 plus or minus the root of 25 minus 4 times 2 is 8 times negative 8 is... Right? So minus 4, that's going to become plus 64 over 4, which is going to be negative 5 plus or minus the root of 89 over 4. That is your exact answer. 89 doesn't simplify. No, it's a prime number. Your approximate answers are... the root of 89 is about 9.5. So negative 3.5 plus 9.5 is 4.5 over 4. So about 1.1. And negative 5 minus 9.5 is negative 14.5 divided by 4 would be around negative 3.5. Something like that. Near that. Obviously, I did not get a calculator and do root 89. I approximated it in my head to be about 4.5. I think 9.5. Because the root of 81 is 9. Everybody good? If you only got to there and didn't get to there, you get 1.5. Yeah? Yeah, sure. You betcha. So last night, I was making me some white man's chana masala. Well, because I'm not from India, so my chana masala is automatically bad, right? See? You guys already, yeah, it would suck. Right? It's, well, just wait till I get to it. So I make it all up, and I'm tasting it, and it's pretty good. And I say to myself, self, it needs just a pinch of salt. Just a pinch. So I pick up my salt shaker, and I start to shake a little bit, and it's one of those salt shakers with a sprinkly end and the full door end. What happened? The full door end bursts open. I was pretty pissed off. So then I thought, all right, I'm going to solve this problem. And I took all the chana masala, put it in a strainer, and hosed it off to wash off all the salty stuff. But it didn't help. It still wasn't very good. Then I added an extra tin of chickpeas. Didn't help. Then I added an extra tin of tomatoes. Still didn't help. Then I made like 4 cups of rice and I mixed it with just plain white rice, and then it was okay. But still not great. I'm pretty pissed off about it. But my curried chicken and my veggie coconut curry, delicious. I put coconut in my veggie curry because I like coconut. It's kind of like korma, but not really. So yeah, I was pretty pissed last night, I'll tell you what. Oh, but my gluten-free naan bread was pretty good. I know I'm saying that wrong, but I don't care. I have some here. It's in the fridge. It's what I'm eating for lunch. Sorry, the discriminant of the roots. This is, of course, 16x squared plus 56x plus 49. And you're going to run that through the discriminant, which is 56 squared minus 4 times 16 times 49. Yeah? And when you do that, you get 0. So, what is the nature of the roots? I will accept 2 equal real roots, which is what it actually is. But I will also accept 1 root because that's what it would look like on a graph. 2 marks. Let's go to light blue. 7x squared minus 3x plus 2. So that is 9 minus 4 times 7 times 2, which is, of course, what? Negative, so no roots. Which is a great song by Alice Merton. If you do not know that song, your loss. It's really, really good. It's called No Roots. But it has nothing to do with the quadratic equation. Louis, you've known me for a year and a half. Do I sing? Okay. I've got no roots, and my home is never on the ground. I've got no roots, and my home is never on the ground. I've got no roots. Ooh, 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 ooh. I've got no roots. Okay? Okay. Thank you. I'll be appearing here till June. If we have some time later, I'll let you hear it because it's a great song. Now, here we're in a bit of a bind, yes? Because it says the best method possible. Now, all of my Brazilian friends are going to expand that out and use the quadratic formula. I know you are. Because that's what you want to do. When I was trying to teach you easier ways to do it, you were all like, no, 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 except in Portuguese. No, 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 I want to use the quadratic formula. And I said, C, go ahead. Of course, to do this, you would not expand it and do the quadratic formula. You would do 2x plus 3 equals 0 and x minus 4 equals 0. 2x would equal negative 3 and x would equal negative 3 halves, or x would equal 4. That's the quickest and easiest way to do it. I don't know why you would choose something else. Go for Myers. Sure, no problem. That's the way it goes. Looking for Mr. Fuge in R301. We've got a complicated classification system in this building. Nothing. I'm going to stop answering. Like, if people really need me, they can damn well walk up. Right? And maybe when they get here, they'll walk past R301 and see, but, whoa, I've been dialing the wrong number all along. Making that whole first page out of 2, 4, 6, 8, 10. What method would you use for for letter B? You would quadratic formula this time. Hey, C. So, of course, the quadratic formula here is negative 4 plus or minus the root of 16 minus 4 times 3 times 2. Do I need to even keep going on? No, I do not. Why? Because 16 minus 24 is negative. Is there going to be any roots? I got no roots. I'm going to play the song, so. But not till later. What about this one? Out of 2. 4x squared minus 16. You could do this and then factor 2x plus 4 to x minus 4. Or you could have done 4x squared equals 16 and x squared equals 4 and x equals 2. Plus or minus 2. Same thing's going to happen here. Right? So that's another 2. I don't care which method you use because they were equally good there. Actually, I don't care what method you use here at all. What about this one? I would do this and factor it to x plus 1 times x plus 1, which means x has to equal negative 1. And what about this one? What would you do there? You could, or you could recognize that negative 3 and 21 share a common factor, don't they? What? If I divided by negative 3, then I would get x plus 4 squared minus 7 equals 0, yeah? And then what would you do? I would move the 7. X plus 4 squared equals 7. Then I would square root. X plus 4 equals plus or minus root 7. And then x would equal negative 4 plus or minus root 7. Then I would never have to square that out. Personally, I think that is the best method. Whatever method you use, if you did it right, you get that. Gouda?
Is that all 2?
Everything's 2. And number 5. Find the values of k for which this equation will have no real roots. As soon as you see no real roots, what are you dealing with? Starts with a D. Ends with a T.
Discriminant.
The discriminant. Yes, the discriminant would have to be less than 0, yeah?
Yeah.
So the discriminant here is B, and that is C. So it is 4b squared minus 4. Oh, not 4, dummy. Yeah, 4. What's A? 3. And what's C? C is tricky. What's C? Yeah, but there's a negative in front of it. So it would be negative k plus 3. Or negative k minus 3, right? Same thing. Now you do that, 4 minus 12 times negative k minus 3, which is 4 plus 12k plus 36, which is 12k plus 40. Yeah, are we still good?
Yeah.
Wait. No, wait. 4 minus 12 times k negative k minus 3. That should be 4 plus 12k plus 36. Yeah? Yeah. And then 12k plus 40 equals 0. 12k equals negative 40. K equals 10/3. I did that pretty fast. Is that right? Does 10/3 work? I think I made a math error here. Time to slow down and look at it again. So I'm 4 minus 4 times 3 times negative k plus 3, which would be 4 minus 12 times negative k plus 3, which would be 4 plus 12 times k plus 3, which would be 4 plus 12k plus 36. I'm still happy with that. 12k plus 40 equals 0. 12k equals negative 40. K equals negative 40 over 12, which is 4 goes into that 10/3, negative 10/3. Now, what happens then? Yeah. Did I screw something up in there? It doesn't feel right to me. There's minus signs all over the place.
Yeah, I know, but in letter C, right?
This one?
Yeah, minus sign is supposed to be for K, not for K plus 2.
I think, yeah. That feels better to me. Yeah. It should have been minus 4. It should have been 4 minus 12k plus. No.
Yeah.
Yeah, plus.
Huh?
4 minus 12 times minus k
Plus 3.
plus 3. 4 plus 12k minus 36. That's better.
Yeah.
12k minus 32 equals 0. 12k equals 32. K equals 32 over 12, which is 8 over 3. That feels better.
Yeah.
Yeah. All right.
All right.
And then let's check. 8 over 3 plus 3 would be 8 over 3 plus 24 over 3 would be 32 over 3. Multiply by 3, 9x squared plus 6x plus 32 And then that would be 36 minus 4 times 9 times... Yeah! Yeah! Okay.
How much?
1 second. Does everybody understand? Now, 10/3 didn't seem right to me because I practiced this a lot. But if you had done what I did and you got to 10/3, does everybody understand what I did here to check? Everybody? I put the 8/3 in for k, and then I did k plus 3, which is 8/3 plus 24/3, right? Which gives you 32. Everybody cool? Then I checked. Then I just ran it through the quadratic equation and checked the discriminant. Everybody good? All right. Making that page out of whatever it was out of. 2, 4, 6, 8, 10. I can't hear you. What? Solve the... Solve... E? Yeah, we did right there. You want to expand this? Yeah, of course you could have. Oh, how to do it? Oh, sure, Deepinder, sorry. So if you're going to open these brackets, did you divide by 3? No? Okay, so if you're going to open those brackets, it would have been negative 3 x squared plus 8x plus 16 plus 21, which would have been negative 3x squared minus 24x minus 48 plus 21, which would have been negative 3x squared minus 24x minus 26, right? Or 27. Then you would have divided out the negative 3, I would assume. Negative 3, and that would get you x squared plus 8x plus 9, right? And then you would factor this, which would be... Oh, you can't factor this. Oh, yeah, you can. No, you can't. You can't factor that. So you run that through the quadratic equation, which would get you, it would get you 8, negative 8 plus or minus the root of 64 minus 4 times 9 minus 36 over 2, which would be 64 minus 36 is 34, 28, right? So it would be negative 8 plus or minus root 28 over 2, which would be negative 8 plus or minus 2 root 7 over 2. Then you would cancel all that and get negative 4 plus or minus root 7. Now, my argument, of course, is that is a lot more work than that. But we get to the same answer. Now, all of you guys often ask, why is my work faster? It's not because I know something special about numbers. It's because before I jump into it, I stop for a second and I look and I choose the best way of all those ways, rather than learning one way and forcing what I need into that. Everybody understand? And I don't remember what this is out of now. 20 perfectly?
Yeah.
All right, I'll get that marked from you sometime in the very near future. Please turn to the page entitled Graphs, I believe. Okay, now, ladies and gentlemen, when I was your age, this is where things went off for me. Actually, it's weird. When I was younger than you in grade 9, this algebra, didn't get it. And then in grade 10, we did trig. And I was like, I love it. Trig is awesome. And then a friend of mine wisely said, hey, idiot, you know how you can't do algebra? I said, yeah. What do you think you're doing with trig? I'm doing trig. It's not algebra. And he said, oh, really? sine 24 equals x over 7. Yeah, 7 times sine 24. Okay, moron. 4 equals x over 7. Well, that's algebra. I can't do it. Which is why I'm so mean to you guys when you try to tell me that line, right? Because you just moved the 7, 2080, right? So when I did trig, and my buddy said, you're an idiot, it's the same thing. I was like, no, it's not. And then I went home and I did all my trig and learned how to do algebra, right? Because you can't tell your friend that he's right. Even in 1990, you wouldn't ever do that. Unless it was a girl that you liked who was right. And then even if she was wrong, you'd be like, you're right. And then she'd be all like, I know. And you'd be all like, yeah. Now go to the movies with me. And then she'd be like, no. And I'd be all like, okay. Anyways, where was I going with this? Oh, right, yes. So then I was cool with algebra. So then all of grade 10, most of grade 11, I'm like, yeah, no problem, got this. Doing some algebra, factoring, finding some roots. And then my grade 11 teacher, Mr. Dodds, his name was Bob Dodds. Doesn't that sound like a snack food? That's what my mom said. I said, Mom, my teacher's name is Bob Dodds. And my mom was like, that sounds like something you would buy in a bag. Nacho cheese Bob Dodds. Right? And I was like, yeah, it does. Huh. Anyway, Mr. Dodds taught us all the stuff, and then he said, all right, now all that stuff, we're going to graph it. And I was like, damn. And then I was screwed for another couple of months. But then, my girlfriend's dad's best friend was my Math 12 teacher. And my girlfriend's dad was the counselor at the high school. And he was checking up on me all the time. I know, can you imagine that? I know, it was very stressful. It was a very difficult year to be a boyfriend that year. So because they were besties, I had to make sure my math mark came up. So I really had to work on graphing in grade 12. So now I'm okay. So the reason I'm telling the story is because even if you're like, yeah, I got this thing up to here, you're going to want to be careful now because graphing gets a little weird. Everybody cool? All right. But it's not difficult because what's this? What's that line? X's. What's that? Y's. Right? It's all just X's and Y's. Doesn't matter what we do to it, it's still X's and Y's. Is everybody good? Okay, let's do some math. A quadratic function. Remember, if it's quadratic, what does it have? X squared. Does it have to be an X? Does it have to be an X? No, it could be any letter, right? But we're going to use X because that's what we like in math class. Does it have to be squared? Yeah. If it's not squared, you're going to get a straight line. If it's cubed, you're going to get something that looks like this, which we don't do in grade 11, so don't worry about it. Squared. So we're going to do the easiest one we possibly can. All right? And that is y equals x squared. Everybody cool? Yeah. All right. Now, what we're going to do is, that's the simplest one. That's the one we're going to work with right now. Now, if I told you to put this on the graph, what would you do to put this on this graph? What mathematical tool would you use? You learned it in grade 9. Actually, you learned it before grade 9. How do you put stuff on a graph? Pardon? You substitute in, right? You make one of these. X and Y, right? Some people call it a T-chart. Some people call it a table of values, whatever. And you put some numbers on there, right? Okay, so give me some numbers. What would 5 really good, easy numbers to use be? 0 would be a good one. What else? 1 would be a good one. What else? Would be a good one. What else? -1 would be a good one. And? -2. So let's do that. -2, -1, 0, 1, 2. What is -2 squared? 4. What is -1 squared? 1. What is 0 squared? What is 1 squared? 1. What is 2 squared? Now let's put them on the graph. Where is -2, 4? Negative 1, negative 2, 1, 2, 3, 4. Everyone agree? Negative 1, 1. 0, 0, 1, 4. And it gives us this nice, smooth curve. That curve, if you remember, is called a parabola. Please notice that because of the squaring, it has to turn back up. Right? Because as soon as you square a negative number, you're going to get a positive output. Is everybody good with the basic shape of a parabola? Yeah? All right. Everything we do is going to be this adjusted in some way. So if you understand this, you're 90% of the way to doing this whole unit. Is everybody cool? Right? Now, what will happen? I went over this way and up 1, correct? When I went over 2, how far up did I go? 4, right? So how far up if I go over 3, where's the next one going to be? 9. If I go over 4, where's the next one going to be? Everybody see the pattern? All right. So that is the basic form. Now, you are going to learn 3 forms. You are going to learn the standard form, which you have already seen, which is y equals ax squared plus bx plus c. You've already seen that one, yeah? You are going to learn the vertex form, which is y equals a x minus p squared plus q. And you're going to learn the factored form, which you have already seen. I just haven't given it a name. The factored form is a x minus d. We always use d. And x minus e. Okay? Now, why do we have these letters here? Why is there a letter there, letter there, letter there, letter there, letter there, letter there, letter there? Because they're just representing numbers that aren't x and y. Okay? In all of these forms, the only numbers that will appear on the graph are the x's and the y's. Does everybody understand? Every other number, A, B, C, A, P, Q, A, D, E, are adjustments to this X and Y. Is everybody good? Yeah? Okay, so let us carry on with the knowledge that you've already brought to the party. From the vertex. What's a vertex of an angle? Who remembers? If I draw an angle, A, B, C, where's the vertex? B. It's the corner of the angle, yes? Apply that knowledge to a new structure. Where is the vertex of a parabola?
The 0.
In this case, it's 0. It's where it turns around, yes? Okay. So the vertex is the point where the parabola turns back, for lack of a better word. Okay? Because a parabola could go this way. Where's the vertex? Right there, yes? Because that's where it turns back. A parabola could go that way. And a parabola can go that way. Sad face. Everybody good? The vertex is the point where it turns back. Now, every parabola follows this pattern unless it's adjusted by a D and E or a P and a Q. And the pattern is simply this. For the first point, you move 1 plus or minus on the x-axis, and you move plus or minus 1, plus or minus 1 on the y-axis. If you move plus or minus 2 on the x-axis, how far do you move on the y-axis? We just talked about it. I didn't make you write it down so you could say it without writing it down, so you could concentrate. How far did we go on the second one? When we went out 2, we went up 4. When I go 3 on the x-axis, what do I do on the y-axis? Plus or minus 9 on the y-axis. What's the relationship? It's the square. Yes? So if I went to the right 11, how far up would I have to go to get that 121? Is everybody good? Can everybody sketch a regular, easy, non-adjusted parabola? Everybody cool? You really need to understand this. Like, we can't go on if you don't get this. That the relationship is squared. Everyone is good? Okay. All right, so, ow, sore leg. We need to get all of these words. All of them, most of them you already know. Okay? So the vertex, we've already talked about that. It's the spot where it turns around, yeah? But we're going to give it a better name now, all right? In grade 11, we only deal with vertical parabolas. So it could be this or this. Is everybody cool? The vertex is that point right there, yes? Everyone agree? Okay. So it is either the lowest point, which is which one, the green or the red? The green. Since it's the lowest point of the green, we call that a minimum. That is a word we are going to use all the time. A minimum, a parabola is a minimum if it opens upwards. Everybody good? You're intelligent young people. If it's the highest point, which is red, what do we call it? A maximum. Is everybody good? Everyone's good? Everyone understands those terms? Okay. All right. The equation of the axis of symmetry. This is weird because there's two concepts here. One, there's an equation. For an equation, we must have an equal sign, yes? But we also have to define axis of symmetry. Think back to the 9th grade. Hopefully your teachers at some point in either the 9th or possibly the 7th grade discussed symmetry with you. Do any of you remember what it means? What? Perfectly equal? The same. Where? On both sides, right? The human face is not really symmetrical. Like your one ear is usually higher than the other, one eye is bigger than the other. But for illustrative purposes, the human face has this kind of symmetry, yes? I'm the same on both sides. I have vertical symmetry. Everybody cool? Do I have horizontal symmetry? No. Do I have diagonal symmetry? No. Just vertical. Everybody understand? All right. Parabolas have what kind of symmetry? They have the same as a face. The axis of symmetry is the line. Oh, wait, I'm not going to write line. In grade 11, it's the vertical line through what part? Right, through the vertex. Because if I draw this line and I fold that parabola over, it's going to be exactly the same. Is everybody cool? Now in grade 12, when you do horizontal parabolas, where's the axis of symmetry? It's going to be there. Everybody good? Okay. Now, that's what the axis of symmetry is, but we need its equation. If it's a vertical line, is it x equals or y equals? I'll remind you. There is the axis of symmetry, right? The vertical line right through. So does it have an x value or a y value? It has an x value, doesn't it? Because it's right there. It's always that. No matter what the y value is, the y value can change, but the x value can't. So the equation is always x equals some number. If it's positive, it's on the right of the y-axis. If it's negative, it's on the left. And it is always the x coordinate of the vertex. Is everybody cool to there? Yeah? All right. We all know what x-intercepts are from our grade 10, right? Draw a line. In grade 10, we had a line. How many x-intercepts does that line have? 1, right there. Will it ever cross the x-axis again? No. So the x-intercept of a line is where the line crosses the x-axis, yes? So the x-intercept of a parabola must be when? If it happens once in math, it happens every time. I drew a line on a graph. It crossed the x-axis, so that's the x-intercept. What then is the x-intercept of a parabola? It's every time the curve hits the x-axis, right? So the x-intercepts are when our parabola hits the x-axis. And we remember that it is always x comma 0 because the y's have to be 0. Now you already know something about this. We only have 3 options here. What is option 1 for x-intercept? It could be negative. I'll draw a couple of parabolas. I'll draw 3. What are the 3 options? Damaris. I could have 2 x-intercepts. Now this should already be looking familiar to you. Wait a minute, there's another thing we talk about having 2 of. What were they? Roots. These are the roots. Or I could have option 2, which is blue. How many x-intercepts? I could have 1 x-intercept, which would mean I had 1 root. What about the green one? No x-intercepts, which is no roots. And see how this ties into what we've just been doing algebraically, right? We didn't put that on the graph. We just sketched it once or twice to show you, yeah? This is what's actually happening. Everybody good? Everybody good? Okay. So what about the y-intercept? Notice x intercepts, y intercept y. How many times will all three of these parabolas hit the y-axis? Once only, right? So if the x-intercept is where the parabola crossed the x-axis, the y-intercept is where the parabola crosses the y-axis. And in grade 11, there's only one of them. It's when x equals 0. So it's 0, comma, y. And in grade 11, there's only one. When would there be two? In grade 12, if we take the parabola and turn it sideways. Everybody cool? All right. Now in grade 10, you learned the words domain and range. Who remembers what they are? Nobody? Damaris, thank you. Yep. So these guys are the independent variables. Where do we put them on a graph? They're on the x-axis. So the domain is all the possible x values. What then is the range? Since nobody's answering, I'm just writing it out. Now, something weird happens here. In math class, if I am graphing a parabola, how many x values can I have?
2.
No.
1.
No. Those are roots. Damaris. I'm graphing a parabola. Any x-axis. Any x value. Because if I graph it, no matter what, that parabola is going to spread out for how long? Forever. Is it going to cover the entire x-axis? Yes. So in math class, all possible x values, math, reality. In math, x is everything, all the real numbers. Is that the case in reality? No, of course not. If I'm graphing a parabola of time against something, can I have negatives? No, because I can't have negative time. If I'm graphing the time I have an investment against the money I'm going to make, is the time going to go to infinity? No, because eventually I'm going to die, yes? So in reality, the domain is restricted. Restricted. What about the range? In reality, what is the range? In math class. Will I touch every single y value? I'll draw a graph again to help you. No, I will not. Y is always either greater than and equal to my vertex, or y is less than and equal to my vertex. Always. And in real life, it is also restricted. For example, if I jump out of a plane and I follow a path to the earth, could I ever have a negative value of my height? No, because when I hit the ground, I'll bounce. Mr. Van B. Last, I'm thinking that for Beth's birthday this year, I'm going to rent her a bouncy castle.
Okay.
So I got one for 2 years ago,
Okay.
but I was doing some research. It's like twice the price.
Okay.
That's inflation for you.
Hey, why isn't a koala bear a real bear?
Why?
It doesn't qualify.
Good night, everybody.
Good night.
Everybody good? Okay, first of all, that was a good one, but it was no, that's inflation for you.
Yeah.
All right, everybody is good? All right, now, listen to me. Talk to your neighbor and tell me A, B, C, D, E, and F for a regular parabola. So, go. I want to know the vertex, the axis of symmetry, the x-intercepts, the y-intercepts, the domain, and the range for y equals x squared. Go. A, what is the vertex of y equals x squared? What's the vertex? 0, 0. Good. B was the axis, the equation of the axis of symmetry. What does x equal? 0. Good. C was the x-intercept. What is it? 0. Only touches it once. D, the y-intercept. 0. Excellent. E, the domain. What are the possible x values I could put in here? X is everything. Because no matter what I enter for x, I can square it, can't I? And F, what's the range? Y has to be greater than or equal to 0. Is everybody good? Can everybody read a parabola? Can everybody put one on a graph? Awesome possums. Turn the page over, and we are going to work with the first of those forms that you have never seen before. We are not going to use a graphing calculator yet. We all know how to graph this one, yes? We've already done it. 0, 0, over 1, up 1. 1, 1. Over 2, up 4. 2, 4. And then, what happens on the other side? The same thing. Over 1, up 1. The y's are the same. Over 2, up 4. And I graph that. Everybody knows how to do that one, yeah? Okay. Now, let's look at this one. Some of you already know how to do this. Please bear with me because most of you won't. How would you graph this? Well, we'd make another table, wouldn't we? And we'd use -2, -1, 0, 1, 2. Agreed? Okay. X is -2. What's -2 plus 3? 1. What's 1 squared? 1. What's -1 plus 3? 2. What's 2 squared? 4. What's 0 plus 3? What's 3 squared? 9. What's 1 squared? 1. 1 plus 3. 4 squared? 16. And 2 plus 3? 5. 5 squared? 25. So let's do this thing. -2, 1, 1, 4, 9, 16, 25. Wait a minute. What don't we have? If I go over to -2, I go up 1. I don't have an x-intercept, do I, Louis? I don't have a vertex, do I? If I do this with the same numbers I'm used to using, I don't have a vertex. Agreed? Okay. But I can see that I'm going over 1 up. How far up? Over 1, I'm going up 3 from there, yes? Which means if I had gone over 2, I would have gone up my 4, yes? So there is my vertex, isn't it? What is it? That's -1, that's -2. What's that? -3. Does everybody understand why? I can see that this point is over 1 up 1, yeah? So this must be my vertex, correct? So what would it be if I went left 1 to -4? What would I go up to? 1. So there is my curve, agreed? What is my vertex? -3, 0, correct? Now, look at the equation, look at the vertex, and tell me if you see a relationship. What's the relationship? That's the equation we're working with. That's the vertex. What's the relationship? He waited patiently for 30 people to tell him what he was wanting to hear. The 3. +3, -3. Look up in here. What number in here is in that spot? 3. So P must be what? The opposite value for a vertex. You can see it. We just proved it, yes? So knowing what you know now, can you automatically graph this? If this wasn't here, it's this, isn't it? But -2. Well, when it was +3, I moved 3 to the left. So when it's -2, where am I going to move? 2 to the right. 1, 2. There's my new vertex. That's the only change that we made from this to here, yes? So no other changes will happen. So when I go 1 to the right, how far up will I go? 1. When I go 2 to the right, how far up will I go? 4. When I go 1 to the left, how far up will I go? 1. When I go 2 to the left, how far up will I go? 4. And there's my graph. Is everybody good? Again, you have to tell me if you're not, or I can't go forward. Does everybody understand that if I put a number with the x, it's going to move that x value? Everyone? Okay. Is there a number with x this time? No. X is not being adjusted, is it? It is still x squared, yes? So if I was going to graph just that, it would look like this, yes? Except I'm not graphing that. I'm graphing that dropped by 4. So when I put 0 in for x, which is that point right there, 0, 0, what's 0 squared? -4? So when x is 0, what does y equal? So where's this graph going to go? Down how far? 4. 1, 2, 3, 4. Anything else going to change? And if I go over 1, I'm going to go up how far? 1. Left 1, up 1. What if I go left 2? Up 4. Left 2, up 4. And there's my graph. Yes? Tell me the relationship now between that and that. Excellent. This is the y value of the vertex. Now, P was opposite. Is y? No, because it says plus Q. Everybody good? Is everybody good? All right. Look at the next one. Am I adjusting both of them? Great. So I should start at 0, 0, shouldn't I? But I have adjusted x. In what direction? I got to go 2 steps. Which way? Right or left? Right. 1, 2. So there's my new x value. Yes? Have I adjusted the y value? I would go up by 5. 1, 2, 3, 4, 5. Agreed? So what are the coordinates of that vertex? 2, 5. Is everybody good to there? Now can we graph it? If I go 1 to the right, how far up will I go? 1. What is the coordinates of that point? 3, 6. If I go 1 to the left, how far up will I go? 1. What are the coordinates of that point? 1, 6. Notice the y's didn't change. What if I go 2 to the right? What will the x coordinate be? If I go 2 to the right, what will the x coordinate be? 4. And I'll go up how far? 4. So this would be 4, 9. Over here, what's the y coordinate automatically? The y coordinate over here is automatically 9. The x coordinate is 0. Is everybody good? Yeah? Prove it. Graph this one. I want to know the vertex and 4 other points. Go. Are you done? How many people need a little more time? Okay. Alrighty. There are your vertex and 4 points. Is everybody okay? Once, twice, thrice. Over 1, up 2. Over 1, up 1. Over 2, up 4. Everyone is good? Which part? Are you able to find the vertex, Rena? Okay. Well, in the regular graph, from the vertex, I go right 1 and I go up 1. Yes? Then, when I go 2, I have to go up 4, right? Okay. So when I find the vertex, I go over 1 from -2 to -1, and I go up 1 from 3 to 4. When I go over 2, I'm at 0, and I go up 4 from 3 to 7. Are you okay? And then I do the same thing on the other side. Are you okay? All right. Let's look at this guy. If there was no negative there, how would that graph look? It would look just like what we've been doing before, yes? That, agreed? Opening up, centered on 0, 0. But there is a negative there. What does a negative do to numbers? What's the word we use? What's the word we use to describe a -3? It is what compared to +3? The opposite. Well, I've got a negative in front of my parabola. What would be the opposite of that parabola? Upside down. Would I go over 1? But instead of going up, where do I go? Down. When I go over 2, I go down 4. A negative out in front flips the parabola. If x is negative, the parabola opens down, which means it has a maximum. So now all of you should be able to graph this for me, yes? Where's the vertex? Vertex equals 5, 6, correct? Out 5, up 6. Negative. So am I going up or down? Down. So when I move out to 6, I'm going to go down how far? 1. What would that point be? Six, 5. What's this point automatically? 4, 5. When I go out to 7, how far down do I go? 4. So what would this point be? 7, 2. What is this point automatically? 3, 2. Is everybody good? Yes? And then we would curve it. Sweet. Now, the last thing we're going to do today is I'm going to show you this one. You're going to try to graph these two. If I was going to graph this, damn, you're off the hook, no homework.